Hello guys, and welcome back to another geography lesson. Now what we've done, we've covered the theory bit. Before we're moving on to the map work, let's just concentrate on the revision exercises and the activities that you got in your workbook, so that we basically can look at the activities, the questions that you can expect in your final paper, and to help you to better understand the questions. Now, our first activity exercise is about a synoptic chart. Now, before I want to continue just looking at the questions, I want you to observe this synoptic chart. And like I've mentioned to you before, there's quite a few clues on it to make us understand the synoptic chart even better. Now, first of all, let's have a look over here. The date, 2010, 01, and the 30th. So that's if you look at the date, what season is this? This is definitely summer. Then on the synoptic chart, we've got some features over there. If you look over there, this is a low pressure. What do we know about the low pressure in the southern hemisphere? Clockwise circulation. Now the reason why there's a low pressure over the continent is because of warm temperatures. The land heats up much quicker than the surrounding ocean temperatures. Now, as you can see over there, we've got a weather station over there. It gives us the information of the weather that they experience. Then we got our high pressure systems over there. How do I know it's a high pressure system? Look at the millibar reading, 1020 hectopascal. There's another high pressure system over there. And by now, we should be able to identify these high pressure systems, am I right? So let's just quickly name them, just fill this in. This is the South Atlantic high pressure system. How do I know this? Because it's over the Atlantic Ocean. The South Indian high pressure system. And then, if you quickly look on the eastern side of the continent, we have a low pressure system over here. As you can see, almost perfectly shaped isobars. There's a symbol, and what do we know that? That's an eye of a tropical cyclone. We know it's a tropical cyclone because it's already been named, Kafi. And what do we know about tropical cyclones? They are named according to the alphabet. So we know Kafi is the A, B, C, the third tropical cyclone for the season. And then over here, we have a low pressure system. As you can see, how do I know it's a low pressure system? Look at the isobar reading over there. It's very much importantly, when we look at different types of cyclones, this one consists of a cold front and a warm front. And as you can see, the system moves from west to east. So what do we call this low pressure system that we see over there? It's a mid-latitude cyclone. How did we know that? In the mid-latitudes over there. So just quickly, just looking, not even answering one question, we know the synoptic chart is in the summer because we looked at the date. How do we know it's in summer? There's a low pressure system over the interior of the continent, and there's a tropical cyclone on the east coast of southern Africa. Why on the east coast? Because warm ocean currents situated over there, and tropical cyclones form between 5 degrees and 25 degrees north and south of the equator because they need a Coriolis force. And then South Africa is situated on a subtropical high pressure belt. As you can see, we have identified the South Atlantic high pressure system. We've identified the South Indian high pressure system, and we have identified a mid-latitude cyclone. How do we know that? Distinctive cold front and warm front, and the system moves from west to east. And let's quickly look at the questions that's being asked over here. Name the high pressure systems, the cells labeled A and B. Let's go back to our synoptic chart. A, our South Atlantic high pressure. B, our South Indian high pressure. So I'm just going to write over here, South Atlantic high pressure system, South Indian high pressure system. Very importantly, matrix, as you can remember, the circulation of air in these high pressure systems are what? Anti-clockwise circulation taking place. If we look at our next question, give two pieces of evidence from the map that this is a summer map. Now we basically already answered those questions as well. First of all, if we quickly look at the synoptic chart, you can see it's summer. You look at the date, and we can look at the temperatures in the weather station model. There's another answer. There's a low pressure over the interior of the continent, and there's a tropical cyclone on the east coast of southern Africa. So that's your answers for number 2. If we look at our third question, that was the second question. Just want to get to the third question. Identify the low pressure cell labeled E. Let's quickly go and have a look at that. E over there. As you can see, there's a low pressure system over there. And that is known as a coastal low pressure. Moves all along the coast. If we look at the low pressure system number E, over there, it's a coastal low pressure system. If we look at our next questions that follow, the letter G indicates a mid-latitude cyclone. Name the fronts labeled F and H. Now we've already done that by just observing our synoptic chart. As you can see, F is your cold front and H is your warm front. Now what have we learned over the past? What basically happens? The system moves from west to east. Cold front tries to catch up with the warm front. Obviously, especially what happens is it creates frontal rain where the cold front forces the warm air to rise, cool, condense, clouds and formation of rain. If we look at our next question, in which direction does this cyclone generally move? And we've discussed that already as well. As you can see, it moves from west to east. Let's continue to our next question. Describe how front F will affect the weather of Cape Town. Now, grade 12s, this is quite an important question, and when we talk about the weather of Cape Town, think of your weather station models. The following we need to keep in mind. If you look at the weather station models, what's the information that's on there? Temperature, dew point temperature, precipitation, cloud cover, and wind speed and wind direction. Now, what do we know? Cape Town is affected by cold fronts usually during the winter, and the climate we refer to is Mediterranean climate. So what's going to happen if this front moves over Cape Town? What's going to happen with the weather? Now, first of all, it's a cold front approaching. What's going to happen with the temperature? The temperature is going to decrease. What's going to happen with the dew point temperature? It's also going to increase because the chances for rain is going to be very good. Precipitation, cumulonimbus clouds building up because that cold front forces the warm air to rise. It cool, condense, and clouds. And cloud cover, the chances are that it's going to be overcast conditions because of the precipitation that will be formed. Now, what will happen with the humidity? The humidity will be high as well, and there will be light to variable wind conditions that will develop. Now, if you refer to the cyclone, the tropical cyclone that's on the east coast of southern Africa, what type of cyclone is Kaffy? Now, it's beautifully shown over there. You look at the isobars, and it's got a distinct eye. It was perfectly shaped isobars, and it's got an eye in the middle. Now, what type of cyclone is it? A tropical cyclone, because it comes from the tropical regions. It forms between 5 and 25 degrees north and south of the equator. Now, that's the correct answer. It's a tropical cyclone. If you look at the next question, state how many cyclones have occurred from this season, including Kaffy. Now, we use the alphabet to state how many of them has occurred in the season. Now, as you can see, Kaffy is the third letter in the alphabet. So that means Kaffy is the third tropical cyclone of the season. So that means there was 2 before Kaffy happened. Now, in which direction does the cyclone move? Now, I showed you it moves from east to west. It's the initial stage, mature stage, and dissipated stage, and then it recurs in the easterly wind belt. Okay, if you look at the movement of it, your notes tells you it moves from east to west. If you look at our next question, there's 2 conditions necessary for the cyclone to form. Now, if you look at tropical cyclones, first of all, it can't form very close to the equator, between 0 and 5 degrees. Now, we already established it is because there's not enough Coriolis force taking place over there. Now, first of all, it needs ocean temperatures above 27 degrees Celsius. Gr12's be very specific that the ocean water needs to be above 27 degrees Celsius, not the temperature. It needs a friction-free surface, it needs warm and humid conditions, and obviously it needs Coriolis force to form. Now refer to the weather station labeled D and describe the weather in terms of cloud cover, wind speed, wind direction, air temperature, and dew point temperature. Now, very importantly, I want to go back to the synoptic chart. Grade 12, you can't tell us, when you answer this question, you need to be specific with the information on the weather station model. You need to give the exact air temperature, the exact dew point temperature, and the exact wind direction. So let's quickly go back to our synoptic chart. Now, as you can see over there, they ask us to describe the weather conditions for weather station D. Now, as you can see, what's the temperature going to be? 22 degrees Celsius. What's the dew point going to be? 15 degrees Celsius. What's the cloud cover? It's clear skies. What's the wind direction? Wind direction is going to be south, southeast. And the wind speed is going to be 10 knots. Keep in mind, if you look at the knots over there, that is 5 knots, this is 10 knots, and this is 20 knots. Be careful for that question to not get confused between your 5 knots and your 10 knots indications. Okay, so that could answer the questions on the synoptic chart and the activity. Now, as you can see, you can basically observe all of that on the synoptic chart without answering all the questions. Our next activity, as you can see on this diagram, shows us valley climates, local climates. Now, without answering the questions, just quickly look at these 2 diagrams and what can we see. Now, first of all, they've mentioned warm air rising. Just going to read. As you can see. Now, and as you can see the valley shape. Now, what type of valley breeze do we experience? Obviously, because of the warm air rising, we know it's daytime, so we can say it's an anabatic breeze. Now, if you look at diagram number B, it's cold air sinking. Now, when the air usually sinks, during nighttime or daytime? During nighttime. So we can identify B as a katabatic breeze. As you can see, the air sinks, and very importantly, you can see what happens over here. The warm air has been uplifted. As you can see, C is known as the what? The thermal belt, or the inversion layer. Because the cold air sinks down the valley, displaces the warm air upwards, and what's being created in the bottom of this valley over here? A frost pocket. Okay, so just let's quickly go and look at the questions. What's the questions that they ask regarding these two diagrams? Name the valley winds depicted in A and B. A, as you can see, is warm air rising, so it's definitely anabatic breezes, happens during daytime. And B is cold air sinking, usually happen during nighttime. As you can see, the warm air has been uplifted, a thermal belt or inversion layer has been created. So that's anabatic and katabatic breezes. Now state one advantage of the wind labeled in A. If you can look at that, if you look at what's the advantage of diagram number A, they basically carry pollution out of the valley floor. And if you quickly look at that number, name the layer labeled number C, and that's in diagram number B. As you can see, this layer over there, it's known as the thermal belt, because the warm air has been displaced by the cold air that collects on the bottom of the valley floor. Explain how the wind labeled by B influenced farming in the valley. Now, very importantly, when we look at B as the katabatic breezes collecting down on the bottom of the valley, the farmers need to be 100% sure what type of crops they're going to plant. Why? Because we experienced the frost pocket down on the bottom of the valley. So you can't just go and plant any crops over there. And industries in the valley, what's going to happen, especially during winter, the pollution is going to be trapped below the inversion layer or thermal belt. So it's going to create more smog with the industries. Right after the break, we're going to continue with some more revision exercises.